Okay. So, hello everyone, welcome to this BioData.pt Talk. In the first place, thank you so much, Dr. Zoran Milosevic, for accepting this invitation. So, today we have a talk with Dr. Zoran Milosevic, a specialist in FHIR, now living in Australia for many years, originally from Serbia. Yeah. So, welcome to Lisbon. Thank you for this time, and go ahead.
Thanks very much.
In the end, we'll do a small Q&A session. So you're welcome to stay for the end and also learn hopefully a lot with your experience. So thank you.
No, thanks very much for that. It's really a pleasure to be back in Lisbon after some 20 years. I think I was traveling with young researcher at that time around Portugal and Spain. It was very nice. I really enjoyed Lisbon, also Porto, and then is it called another university town? Coimbra? Coimbra, yes. That was really nice. I really enjoyed that. So Portugal is a nice place, and great that to see it back. So today I'll just talk to you a little bit more about FHIR standard, and in particular, about how we can use FHIR to empower data-driven healthcare. The reason I'm here actually is that there will be an interesting event at the end of this week, from Wednesday onwards, called FHIR Kent in Cascade. So that's the reason I really wanted to come and talk about future developments of FHIR with some people who are really founders and creators of FHIR. And it's going to be really interesting, a very technical meeting, so I look forward to it. But then I thought it would be really great to see you guys, especially because I met Jose in Vienna maybe a couple of months ago at the EDOC conference. So I'm a consultant, but I used to be a researcher. So and I'm still publishing and writing papers as much as the consulting work allows you to do that. So I am from Brisbane, Australia. I don't know whether anyone has been to Australia yet. No. It's really far away. So, but it's really nice country, beautiful country. So what I'll be really going through is starting with some of the traditional consent challenges that I assume you might have encountered yourselves doing research and exchanging data, among various participants in doing some research. And I've outlined some of the current challenges with doing paper-based consent and doing traditional consent, and how we can start moving into in terms of computable consent. And FHIR consent does start with, it's a good basis for adding more expressive semantics on top of the main FHIR. So I'll talk a little bit, that's how I'll start with. And then I'll probably give some 5 slides summary of FHIR standard for interoperability, so that at least, for people who are not familiar with FHIR, you know where to start and what to do. And then I'll talk a little bit more about the semantics of how you describe policies associated with consent, how we describe obligations, permissions, and prohibitions based on consumer preferences. Consumer preferences, but also reflecting regulatory policies, obligations that researchers need to satisfy. So I'll talk about that. And this is more a researchy kind of stuff, about which I presented maybe July in Brisbane at the Health Informatics Conference. And then I'll talk more about the computable consent framework, which is about FHIR consent resource plus the semantics coming from the ODP standards. Has anyone heard of ODP standard before? It stands for Open Distributed Processing. It's not health standard. It's more a standard for describing, semantics of distributed systems, exchange of data, interactions in distributed systems, even across federated environments. It's a very rich standard that I happen to be involved in some of that when I was a junior researcher and working in one of the research group in Australia called DSTC, stands for Distributed System Technology Center. Then I'll try to reflect all these abstract terms, well, conceptual terms, I should say, and I would try to consider them in terms of a clinical trial use case. To what extent you guys are involved in clinical trials? You're not, okay. I was just thinking that this might be closer to you, but you're more in genomic research. Okay, there is no really clinical trial to do that yet. Okay. Okay, and then I'll talk about next steps, and then I'd really like to understand a bit more what you guys are working on, and then at the end there will be group discussion to see to what extent some of these ideas are of relevance for you and what to start with first. So in terms of consent management challenges, first issue is lack of standardization. There is a difficulties in sharing information about consent. So if I'm a patient and going from my general practitioner and then need to go to specialists, each of the organization has its own consent forms, which it really makes it difficult to exchange among an electronic form the data about consent. So if a patient on his journey is going from general practitioner to say specialist, and then ends up with some university hospital, and in which case some of their data may end up are able to be used as a part of clinical trials. There is quite a lot of different interpretation of what consent means. You want to preserve that what patient has allowed to show. So there is also limited granularity in terms of how you define data use permissions. Defining, and this is really coming to the access control. FHIR has interesting approach for that called Smart on FHIR, which is really talking about defining access control and scopes, and really I'll talk a little bit more about that. By the way, how many people are really familiar with FHIR or have seen or used FHIR? Not really. So it's good that I'm giving you a little bit of summary. Really highlights presentation. Okay. Then talking about consent first, it's also difficult to update new data types and usage scenarios. I know in some of the developments in Australia, some of the genomic research, they're dealing with needing to define dynamic consent, how things change, how patients change their decision, their preferences during participation in some genomic trial. I'm happy to send you some information about that. And then they're referring to this as the dynamic consent. So see, it's quite a lot of to talk about consent as a thing that you really need to have more flexible way of expressing and supporting. Limited patient control, how the data is used and shared, and their interpretation. So I as a patient may allow my data to be shared with my GP, but to what extent that GP respects this when sharing information with someone else, with laboratory or with specialists. And then there is only one step in chain. What about 2 or 3 transitive interactions? You lose all that information, so you really need to have a way, if you want to respect patient control, to have a really clear way of expressing the semantics. And I think in general, there is a bioinformatics research is quite complex. There is a dynamic data sharing, derived data from one to another research project. You really need to define different analysis pipelines, different data that you might not do in previous research. So you need to have a way to refine the consent. And last but not least, is ethical and legal considerations, how we present this in a way that you can be computable and then you can enforce it. So that's really calls for a computable consent framework where you need to have a more flexible and adaptable approach. Reflecting research needs, consumer preferences, but also new technologies as they come, new devices, new sources of information. You really need to reflect on how you can access patient information about it. And then automated consent enforcement. If something goes wrong, you would really like to have a way of enforcing that. So then you really need to have machine-readable consent policies to express automate checking and enforcing. Then facilitates data sharing. As I said, you've got researchers among various institutions. You really need to preserve what was agreed by a patient at the beginning of the research. Data security and privacy, important one, to deal with, to protect information about patient. Important issues about transparency and accountability. You need to have a clear communication of consent terms to participants and researchers, and then maintain and provide auditing of all what's happening at the time. So you really need to have a traceability of events. So you can then look back at history if needed. So this is really about setting the scene for this presentation, but I'll just give a little bit summary about what HL7 FHIR is, and I know Jose asked me about that, and Jorge as well. So I'm providing some very high description about what FHIR is. It is a standard way of representing representing healthcare information. And it is done through defining information components, which are called resources, which define specific type of healthcare information. And normally it is done through using JSON and XML. And as you can see here, this is an example. If you see my, let's see my notes. So that's fine. So you can see on that presentation of a patient resource, you've got a UML, XML, JSON representation, and even the turtle, which is more about RDF kind of description of resource. But predominantly developers use JSON to represent information about patient. But this what you see is a logical representation of patient, which has patient as a resource, which has a number of attributes: identifier, active, name, telecom, gender, and so on and so on. This is just a fragment of that resource, which is probably 3 or 4 times longer than this. So this has most information that any representation of patient requires. But then you might need to tailor this for your definition of patient. That's FHIR is really covering 80% of common data, but allows a way to extend it and tailor it in a controlled way, so that you can allow exchange of that new type of information. So I'll talk about extendability of standards and adaptability and applicability to particular use in a particular situation scenario. Then, so the example is patient observation, medication, and many other resources. There are about 150 resources that were developed after so much work in international standardization meetings. I was involved in a number of these over years. There are data types. So within each resource, as you can see, you've got the attributes, which are active, name, but each of these is characterized with its data type, which can be string numbers, terminology codes, and others. And then, as I mentioned before, extension is an important mechanism to add new data elements. So, for example, you have the new data that you want to share for your research purpose. You need to define new data type for research. And then profile is a way of extending the existing resource, for example, patient, for the needs of particular jurisdiction of use. For example, in Australia, we have AU core representation of a patient, meaning there is all what is there, but you need to have specific way of representing postcode, specific way of representing gender and names. And I'm sure in Portugal, if there is a work going on within HL7 Portugal, there should be a way to kind of tailor this for Portuguese type of information. So this is about profiling and extension of FHIR for particular use. So FHIR developers, FHIR designers have come up with 80-20 rules, where 80% is about generic type of information that is applicable across any jurisdiction, but 20% is to be tailored, and you need to have a controlled way of doing that. So there is a lot about this extension profiles. We don't have really time to go there. There are quite advanced topics there. But then also there are references. Each resource can point to another resource. For example, it's a consideration about patient vital information. So there needs to be a reference between patient and observation, and so on and so on. And finally, RESTful API is that allows accessing machines to access data about other resources. So if you go to this website, you've got continuous integration build.FHIR. So as you can see, we'll have a number of type of resources here. You've got basic, framework, which is about foundation. It's more really IT stuff here. You've got XML, JSON, RDF data types, and all that, which is at foundation level. Level 2 is supporting implementation and binding. So this is really about more machine-oriented way to deal with interoperability issues. This is part of that is terminology representing code systems, for example, SNOMED, CT. But anyway, so this diagram shows about all this information about relationship between them. So you can imagine about them. You will see it in a presentation that I shared with you. And this is really showing about FHIR extensions, that mechanism that I mentioned to you before, which is about how you extend FHIR for particular use case. So it may be for needed in research, for example, if you need to define new resource, extension of your existing resource. For example, there is a research plan, you want to refine it for your research plan for genomics in your projects. So the way of doing that, FHIR has a thing called structure definition, which is a concept which is defined to define new type of information, new type of resource, but based on the existing resource. So for example, that it may be structured definition for Portuguese or Portuguese research, whatever you call it, and then it would make use of the existing FHIR research plan resource. And then it might need to have extensions to do with specific data type, which might use. So this diagram really shows, and that kind of relationship between concepts used for extending FHIR, which is called structure definition extension, and then using resource for example, patient resource, which I mentioned before. But you can use any of those 150 resources to extend for your particular needs. Now, the kind of more advanced way of defining profiles is through what's called here implementation guide. So implementation guide may be having a number of resource profiles that say implementation guide for your project. You want to define it for particular research within Portugal or across project with other participants in Europe. And then implementation guide will have a number of resource profiles which are already extended for your needs. It's quite advanced way, but it is a way that you can support computable exchange and interoperability between parties. There is also a very nice way of defining those implementation guides. In the past, it was quite a complicated process. About 2 or 3 years ago, there was a new a DSL tool for creation of your IG, domain-specific language tool for defining your FHIR IG. So it's quite easy now so it shows on the left-hand side representation of that information in a way which is quite usable. So, and it's called FISH, like FHIR shorthand. And it was developed by a US company, MITRE, and then it now becomes, it was delivered and shared with the HL7 International. So you can access that and define your own implementation guide, meaning defining your own set of resources which you need for your project. But once you have it, using that this quite nice way of representing FHIR, then you can create JSON format for that, which otherwise it would have been really very, very difficult. And I remember from early days it was difficult. So using research, so as I mentioned, we've got the value of FHIR for me is it supports standardized data exchange, facilitates data sharing, enables data-driven insights, for example, through analytics. There is a new development called new SQL and FHIR development, which was just proposed over the last few weeks, and that's going to be also discussed in FHIR Camp in Cascais. There will be several guys who are involved in that, and I'm happy to share all that information with you as we go. It can be used also advanced precision medicine, and there are already several resources available: research plan, research subject consent. Some research, it seems this slide also is using some maybe PNG format, which, okay, we don't need to worry, we go to the next one. One thing that I mentioned to you before is FHIR consent. It's a resource that defines in a more machine-readable way of information related to consent. For example, you have definition of who is grantor, who is grantee. Then you can talk about different type of consent. At the moment, FHIR consent is very much focused on privacy consent, but there would be also consent for, say, medical research, or another one for medical delivery, in which you as a patient agree to share, to participate in particular interventions. For example, you had surgery, you need to document that you have agreed for this surgery to happen. But FHIR is very much focused on, at the moment, 5% is on privacy consent. Now, the thing about this consent is that you see that there is FHIR currently has a very simple consent support, machine readable consent, because it does define this metadata. But in order to be able to deal with more computable expression, it has pointers to that external. It has ability to point to this external computable policy language, and this is where my interest is in coming up with powerful framework for defining obligations, permission, authorization, delegation, all, if you want, expressions in a separate domain-specific language that you can use, that FHIR consent resource can use and leverage. So I have developed, presented a couple of papers on that, happy to share, but this is really not subject of this discussion. Just giving you what is currently possible and what you might need to do if you want to do better sharing of information. You really need to rely on external policy language. But even this kind of basic FHIR consent, it allows you to define what you as a patient is allowed to permit to share, what is a permission that you allow to share with doctors, or you deny to share information about your research. So the thing which I mentioned before here, the computable policy language, it's a difficult area at the moment. There is a work going on in access control mechanisms, but there isn't much, wide use of extension of the description of obligation, permission, prohibition, and all this, what is referred to as Deontik concerns, Deontik concept, because it's subject of the Deontik logic thing. So we kind of rely on that open distributed processing standard that I mentioned before. It's not widely known, but there is a significant, knowledge there about defining the Deontik and the computability concept that you can use to extend your consent, but you can also use as a way to better specify dynamic workflow across various participants in which you show about responsibility from one party to another one. In the past, I was involved in this work, and some 10, 15 years ago, we published a book which talks about this standard because it's very hard to be reached, hard to read that standard. So the book is facilitating reading about that. So about what this standard is, it really talks about how we can group different parties together, how they can be structured in terms of collaborations, which are referred to as community. And community is a set of roles which has a kind of representation of what particular individual parties or machines can participate in this grouping to achieve particular objective. And that the behavior is governed by those policies, by the obligation, by permission, by prohibition. So in this case, we've got care community. On the right-hand side, you've got research community, where you've got a subject, a researcher, agent. And this interaction in that community is governed by policies. And then you can have a different individual parties or objects filling in those roles. But the whole template of interactions is staying the same. By doing that, you preserve all what you have agreed in the past. And it's quite a powerful way of describing interaction in the system. Now, things are quite complex because, these policies, when you talk about policies, what a policy is from, a semantics perspective. So it is any constraint on behavior. Behavior can be an action, interaction between parties, events, processes. And then on top of that, you've got those Deontik concerns such as permission, prohibition, which in standard has captured in terms of separate objects, which are called permit, burden, and embargoes, and they can be passed across participants in a system. And by doing that, you allow sharing of responsibility across different parties. The standard also talks about speed checks, which is about how you request information from one party to another, how you represent orders, promises, and many other things. And on top of that, you have a number of accountability concepts, such as how you define delegation from one party to another. What the delegation really involves? What are you delegating? Are you delegating obligation? Are you delegating services? Are you delegating responsibilities? But even these need to be represented in a computable way. In access control systems, you do have certain small, limited support for delegation, but you need much more expressive way of describing this delegation across workflow. And then FHIR and there is a lot of potential for adding this kind of workflow. So this is what I'll be talking at the end of this week in Cascais. Now, this powerful way of representing obligation permission is in the standard captured through what's called Deontik tokens. So they are tokens similar to the access control tokens, which carry information and encapsulate permission or prohibitions through a permit. For example, consumer has permit to access its own HIR, electronic health record, but clinician has obligation, which is burden. It's captured as an object because you would like to be able to share that information across parties as you authorize, you as a consumer authorize a clinician to access your information. So as you can see here, you're passing on information from consumer to clinician, after the factor authorization, which is that special type of speed check, you essentially have ability for clinician to inherit that permission to access patient EHR, but also you want to be able to have a finer grained way of expressing prohibition. You want to access all that data, you give permission to access all data, except, for example, mental health data. So you need to have a way of quickly representing that information about a particular patient. So this is where you need to have a suitable way of describing this information. And then you want to also delegate this to, say, clinical decision support system, which is a system that you engage, you as a researcher might engage, through, say, agent AI or as of recent times, or clinical decision support. So there is quite a lot of work I've been presenting over the last couple of years in terms of how we can come up with that old policy language that we can use as a part of consent, but you can use also as a way to compose a FHIR workflow. I won't bother you here. Essentially, the approach, we don't have time to go into this, but we go from the meta model which describes the key concept of this enterprise language. You then represent it, develop a DSL to reflect that. Here it shows a concrete syntax, for example, how I can represent that using those concepts of permit, the burden and other things. There is some interesting papers I'm happy to share about this particular piece of technology. We are using text tooling as a way to define new DSL. Really quite a lot of detail. I'd rather focus on that concept of community, how I mentioned, and then how we can represent consent community. What are the parties involved in consent? The community. Consent, we've got a grantor and grantee, in which grantor gives permission to grantee to access the information. It can be to clinician, to researcher, over accessing the individual health information. And there are a few other roles in this particular diagram, such as consent authority, which is responsible for keeping information about what the patient has agreed. In the past, I've put a couple of papers to do with consent community model for general practitioner, but this is applicable for more advanced development in the context of clinical trials. So this diagram shows all these different roles in the community called consent community. And that also is based on the standard which I mentioned before. I won't go into this DSL support. This is the work which we've been working on. But you can see that there is quite a lot of need to go into understand really what each of these concepts represents. This slide is about coming back to FHIR. So how I can describe, how I can start from natural language consent, how I can describe it in terms of permission, prohibition, and obligations, and then how that information can be either represented to a particular DSL, so see the point 3, Or I can ultimately go, don't worry about DSL that we've been working on, but we can just try to apply this conceptual framework of Deontik and accountability concepts, and then to look at how I can extend FHIR resources as they are, without worrying about consent, without worrying about DSL, and do that natively. So this is a work that I'll be discussing at FHIR camp later this week as well. Happy to talk a little bit more about this, but it is quite advanced, that bit. This diagram shows how we have integrated the DSL compiler for describing policies with the FHIR ecosystem. You really need to apply. We looked at applying mediator pattern. On one hand, you've got your FHIR ecosystem, such as this one here, where you have a number of resources. You've got FHIR consent, you've got research subject, research plan. So you've got on that one on the left-hand side. On the right-hand side, you've got this DSL compiler done in Python runtime through using that text support. And that's a way of separating completely FHIR development from the policy engine development. But it is really questionable, whether you want to maybe even consider FHIR extensions, and profiles as a part of policy integration. Quite a lot to talk about this as well. But I think I'd probably come to the point where we can, I'd like to understand a little bit more from your end to what extent you really need to worry about exchanging data in the context of your research, to what extent consent is something that you were looking or you need to look more in detail. And before I do that, I just want to say that there is quite a lot of development in research community using different kind of standard called OMOP Common Data Model. I know it's used in research here in Europe and also in the US, which is really not about FHIR exchanging data. It's really about representing information about necessarily for research. It is standardized data model for observational health data, including genomic data, and well suited for large-scale analytic research studies. But there is also recent work going on in terms of OMOP and FHIR mapping efforts, because they're different but overlapping efforts, and there is obviously value in trying to bring them together. And I think we are coming to the point where, I'd like to discuss various issues that you might have, your challenges that you might have in your research, and then with the aim of possibly consider submitting a paper to CBI 2025 and IGA 2025 here in Lisbon about which I think present and say something more about that.
It's going to be the first week of September, by the way.
Sorry?
It's going to be the first week of September.
Oh, first week of September.
Okay.
Okay.
So looking.
Right. So I'd like to open this discussion floor for any questions or any suggestions or any challenges you have, and how you see your work being linked as a part of overall larger Portuguese, I guess, development, both in terms of Department of Health that you mentioned before, but also European interactions and broader. So, any questions or anything to share? Or?
So maybe I can. I don't know if you're aware, but BioData is kind of hosting the genomic data infrastructure project, which is a European infrastructure project. So we have the task of hosting genomic and potentially clinical data. Right now, we don't have any actual data, but we will supposedly have that data once the politics of the government
Sure.
is sorted. And so I think we definitely have to to handle consent at some point. Once we do have the data, and supposedly the data is private, but there has to be data access committee, there has to be consent given to parties that want to access that data. So that's something we definitely have to be on the lookout for, and I think this is a promising approach to handle that.
Apart from that, BioData, we're the Portuguese node of Elixir, and Elixir focuses a lot in interoperability and connecting infrastructures. So this is also very helpful for people working in the related health data and so on. So yeah. Anyone online wants to comment or make any questions to Dr. Zoran? Zoran.
So I have one question. Maybe what is with vocabularies about these consents? Do you have some published vocabularies?
You mean vocabularies about
Yes, for some metadata you need also vocabulary, for example, for different kind of consent, etc. I don't know if you have this kind of.
Interesting. I am not familiar about any systematic way of capturing that information. Like 3 or 4 years ago, we were involved. I was involved in some HL7 standards for consent management. I'm happy to share that information with you. It's quite, it's about 200 pages document, but I don't think it's, well, it's more vocabulary in terms of defining semantics of what consent is, but I don't think it has too many type of consent.
But there is also another thing. If you have a written consent in text, you need to extract features from this consent if you want to make, for example, a workflow, what is possible to do with. So you need some features, but for these features is good if you have defined terms.
Yeah, sure. So I had some thoughts about that. I'm not aware that there is any, systematic approach to doing that. My thought was, in one of the previous slides I showed, and I didn't talk much about that, is using, no, I don't have it here, oops, to leverage LLM tooling. So I played with some of the students at University of Queensland. I'm also involved in some of the project on digital health there. So we were thinking about using some of the LLM tooling to go and scan through your particular consent in natural form, and then you can say, well, I want you to your assistant, AI assistant. I particularly like Claude. You can say, well, I can represent my consent. Can you represent in terms of obligation, permission? All these concepts that I come up with, and it's I'm quite happy with the outcome of that analysis, and so I think this is a way to start. So on one hand, capturing the semantics through knowing what exactly is what you're looking for, which is through that semantics framework coming from the ODP standard, but on the other hand, using automated way to scan the natural description of the document and come up with some good structured representation of the consent. But obviously, you need to have a human in a loop to assess this and verify this. But I think this is a really good, promising approach. But in terms of the existing, coming back to what I said before, happy to send you information from HL7 community on consent management. And it has few models which have maybe related to what you are asking for. Happy to discuss this offline as well.
Thank you.
Comes to your question of infrastructures. So, is this hosted here in Portugal?
Yes. So that kind of forced sense that in Europe, countries have to host their own genomic data of their citizens. So we can't send our genomic and data and clinical data abroad, so we have to host it within Portugal, and BioData is tasked with hosting the genomic data in the scope of GBI.
But you were also saying before it was a European project, isn't it?
Yeah. So it's a federated solution.
Right.
So we have
federated solutions.
So it's the metadata will be public, so anyone can see where the data is, but the data has to be hosted physically in Portugal.
And you have to request access.
Right. And how you actually give access, probably the data itself will never leave, just give access to the environment.
So, by the way, in Australia, do you have a common legal framework for all of these, or there are changes from provinces to province?
Well, there is a framework being developed for a trusted framework for consumer-oriented way of participating in health exchange, less research, more health exchange, and I think there are some indication. I cannot comment on that, but I think there are some indication it's going to be similar to what in the US is called TEFCA model, trusted exchange model, as part of their health information exchange. It is very slow process.
But is there a strong common legal framework all the country, or in provinces there are big difference or important differences?
Yeah. It is a legal framework, it is a regulation, but I wouldn't say it is strong legal framework. So it's being developed. It's unclear really, but there is obviously the federal government will mandate use of FHIR across all the participants. So pathology providers, hospitals, that is vendors supporting hospitals will need to use a FHIR. So for example, Oracle, through previous Cerner system that they acquired, they need to support FHIR. Epic supports FHIR, of these big ones that are in Australia for the hospital systems. But a lot of small companies are using. Yeah.
Now, an information systems question, because every time you say standards like this and FHIR, of course it is a high-level standard, because as you explained, there are lots of things that depends of profile, specialization, local. So when it comes to implement local solutions with this, we have to customize a lot of things. So it's the mess, right?
That's right. Yeah.
So in your experience in Australia, what is the level of mess in this moment?
It's getting better. It's getting better. I mean, HL7 Australia is becoming really a good mandating body to do that. And there is a recent development called Spark. Happy to send you information about that, where there were two projects involved. One is e-requesting. Another one is common data elements. And there is a very much mirroring international HL7 standards with the whole processes involving. I'm involved in a number of these requesting where there are 70, 80 participants coming. There is a process, there is a balloting process, it's quite an involving process. It would probably take a year or two for this, at least, that FHIR bit to be established for use in Australia, because there will be need to define, what are the data elements needed for example, representing patients? What is a referral? What is the request? What is pathology looking for? Like, all that information is going through that standardization process. It's expensive, but.
So here in Portugal, we also have a commitment of the healthcare system to commit with FHIR. So it will be interesting to have a discussion on that next year. So it's a challenge for you if you want to organize a focus session on this, a workshop. Let's think on that. Yeah.
Did you say TEFCA as well here, no?
Yes. No, just they have a broad approach to FHIR. So what I've been understanding so far is that it's their internal standard, but it's not clear what is from the outside. So probably you'll learn more than us about that next couple of days. Because you'll be with the people that I think are advising on that. We don't work with them directly for no reason, so just it happened. So it could be interesting next year. Using the opportunity of the conferences here, we are planning.
We can probably establish some workshop. Yeah.
Okay. So let's think about that. And that's of course for BioData, this bridge with the outside of the pure medical information system, right?
It's interesting when you talked about federated kind of relation between, say, Portuguese and other European countries. How is that? Is that regulated through some kind of contracts and agreements between parties?
It's still a moving target. It's still in discussion. That's part of the problem to be solved. Yeah.
It's being discussed an edit, so a central data governance model. It's still under discussion. So.
But by the way, in the FHIR initiative, Australia also demonstrated interest in joining. So the FHIR initiative is a European-born thing, but there are expressions of interest from Australia and Canada to at least they are following what has been done. So
so FHIR is a genome.
How you call it?
FHIR. So it used to be EGA.
It started with EGA, European Genome Archive.
Right. Okay. Sorry, I was not.
So FHIR is the federated.
So it started as a single thing that was in EBI, and then they realized no, but people can't deposit their European data here because they need to keep it in their country. So now let's have a federated solution.
So very good way of doing that. I think this is
and there I don't think there is an official policy. Like if you want, you can set up your own local EGA node and tell them, okay, we have an EGA node here. You can collect our metadata. There's not like a centralized contract.
No, there is. There's like a contract in which you promise to deliver the service for some years, and you have to follow some rules, namely security rules and SOPs to keep it more or less homogeneous between the whole operation. But yes, FHIR is mostly a service to the research community to hold genetic and phenoclinical data.
okay.
It's also interesting.
So the problem is special complicated because, as you explained, it is already complicated from the clinical side, the privacy of the patient data, etc. But that's for clinical, so the patient is an interest stakeholder there. But when it comes to research, so it's another world, right? So that's why it is so complicated.
Yeah.
And also this distributed framework, even in Portugal, it might be distributed because, for example, we have a system where we have a national healthcare system, but also private hospitals, and etc. Okay, so there are many concerns. So sometimes they go in the same direction, other times no.
I mean, from our experience in Australia, I mean, I'm a member of HL7 Australia, and I'm seeing quite a lot of good development over the last maybe a year or so, but this was made possible by federal government passing good funding to an organization which is, well, to the community, but the community is run and facilitated by that organization called HL7 Commonwealth Science and Research Organization. And they have established a good, you need somehow people who are going to run the process. You know, they're technical people, but they also need funding to run the process. So it doesn't come as free, you know. So, but with this funding, over the last maybe couple of years, it started really becoming more community involvement. So with these two projects, so that's probably started maybe 18 months ago. And with these community projects, one focus on e-requesting, another one on the core data within Australia. There is community approach where there is vendors involved, where there are clinicians involved, there are researchers involved. Some of the CSIRO has that SNOMED CT support that I'm happy to give you contact with those people if you're interested in terminology with SNOMED CT. There is a lot of rich framework going there, and that was developed over 10 years. So the support for SNOMED was developed differently, prior to FHIR, but it is now very well integrated with the FHIR development. Some of my really good colleagues there, are involved in that work.
Okay, remember, I did work with CSIRO many years ago with libraries work, when it was the same problem, but instead of genomics was books descriptions. CSIRO was very involved in some of that.
No, there is a really good development, as you mentioned now, as you also, Jose, mentioned, the focus is moving more into giving consumer more expressive way of dealing and knowing what the information is used for and how that information is passed across. It's going to take years for this to become a more consumer-oriented way, because in the past, the funding model is there, doctor gets all the data, general practitioner, and they do whatever they need. You just blank, sign as a patient that the data is used by your GP, and then it's not research, but
in your department, that's so it's actually very hard. The doctor has your data for clinical purposes, but even the doctor themselves cannot use the data for research unless they have explicit consent for that, and then sharing the data is an idea.
Yeah, no, the same thing. Sorry if I didn't. I give information to my GP, and they don't do it for any research. It's really for involving other practitioners, so they don't need to ask me. Well, actually, there is national rule now saying that I'm allowed. Do I agree for my pathology results to be stored in the national, repository? I can say yes or no. But then the doctor can send information to any specialist, and it is referring me to, say, a pathologist or to cardiologist. They have a right to share all my, shared health summary with them as well. So. But they don't have obviously right to share information for research, but it's really just for clinical.
Okay, thank you so much. We are already at time. Any last questions from online people? Because here face to face we will have the opportunity of making some more questions at lunch. So if there are not more questions online, let's thank one more time Professor Barbinha for making this contact, and thank you Luciana for the logistics, and see you next time.
I look forward to talking to everyone. I guess you people on the Zoom community as well.
Thank you.